Hi, my name is Izzy Marino, and we'll be solving half-life problems today. The problem given is the decomposition of a hypothetical compound, XY, is a second order in XY and has a rate constant of 7.02 times 10 to the negative 3 at a certain temperature. What is the half-life in minutes for this reaction at an initial concentration of 0.100 molarity? The first step to this problem is we're going to notice it is a second order reaction, so we're going to use our second order equation. So our second order equation is written here, and it's just 1 over our rate constant times the initial concentration given. So we're going to solve for that here. 1 over 7.02 times 10 to the 3, 1 over moles times seconds, and then multiply that, our rate constant, by our initial concentration given. And that, our units will cancel out, and it will leave us with our 1,424 seconds. The question is asking for this in minutes, so we're going to divide by 60 seconds so we can have this problem in minutes. So we'll have 23.7 minutes. The second part of the problem is asking how long will it take in hours for the concentration of XY to decrease to 12.5% of its initial concentration when the initial concentration is 0.200 moles. So here, to determine the time it takes for the concentration of XY to decrease to 12.5% of its initial concentration, we can use a second order rate equation. So we have where XYT is the concentration of XY at a time, XY naught is the initial concentration of XY, and K is the rate constant, and T is the time. So here our question is asking for how long it'll take in hours, so we're going to solve for time. So we're solving this equation here for time, dividing by K and isolating to have our variable to have our final equation of 1 XYT minus 1 XY naught is equal to T, and all of that is over K. Now we're going to solve and figure out what we have as our given. So we have our initial concentration of 0.200 moles, and we have our time here, which we're going to multiply by the 12.5%, but when we take 12.5 divided by 0, we get 0.125 as our decimal, multiply that by our initial concentration to get 0.025 moles. And then we have our rate constant as well, which is given. Here we are just going to plug everything into our equation, our given values. So we have 1 over 0.025 moles, which is our concentration at a time, minus our initial 1 over our initial concentration, all divided by our rate constant. Our molarities are going to cancel out and leave us with just seconds. So we'll have 4,985.754 seconds. But we want this in hours, so we're going to use some dimensional analysis. So we'll have, there's 1 minute, or 60 seconds rather, in 1 minute, and then 60 minutes in 1 hour. So after our dimensional analysis, we'll receive T is equal to 1.38 hours, and that will be our final solution for the problem.